Hi, my name is Brandon Graisley. I'm a high school math teacher, and today I'm going to show you how to factor simple trinomials. Simple trinomials are trinomials that have the coefficient of 1 in front of the highest degree term. So this term here has the highest degree. It has a 2 as an exponent for the x. This is a lower degree. It only has a 1, and this has a 0 for the degree. This is a constant term. But there's a 1 out here in front of this x. If this was a 3 or something, that's not a simple trinomial, and we're going to do that later. So here's a simple trinomial. Let me just show you a quick example of where these numbers come from that we want to try to end up with. So factoring means that we're going to break this apart into 2 or more factors or things that will multiply together to give us this expression if we were to simplify it. So for example, if I start with something that's already factored like this, here I have a binomial, and we're used to expanding these. X squared plus 2x plus 7x plus 14. If you're not used to expanding those, you should back up and take a look at the binomial expansion stuff from before. And let me simplify this. 2 plus 7 is 9x, and plus 14. So these are the two sort of forms. This is the expanded form and this is the factored form. And so now we're going to go from this form back to that form. Well, let's just see how we've done this. Here I've got a 2 and a 7. You can see it's right here, 2x and 7x. And those are going to add up to this value here, 9. So 2 plus 7 is 9. And here, my 14, that came from 2 times 7, 14. And x squared is just x squared because there's nothing in front of the x, and that's important that there's nothing out here. Otherwise, you can imagine this gets a little bit more complicated. So in general, we have this same sort of setup. We have x plus, I'm going to use the value b to represent a number. And we have x plus, I'll use another value, d to represent a number. And when you work this out, you have x squared plus bx plus dx plus b times d. So this is sort of the general form for expanding binomials. X squared plus b plus dx, did a little common factoring of the x there, plus b times d. So my final expression then has b plus d. These two numbers add together to give me this coefficient, and b times d, the two numbers multiply together to give me the constant term at the end. So let's look at the expression that we have up here. X squared, I'll just rewrite it here, x squared plus 5x plus 6. I'm looking for two numbers, I'll call them b and d again. I want it so that b plus d equals 5, and b times d equals 6. And there's a bit of an art and some practice to this, but I'm going to notice that these numbers are both positive, so I'm going to have two numbers that are positive adding together to give me 5 and multiplying together to give me 6. I know that 6 is made of 2 times 3, or it could be made of 1 times 6. So I'm going to maybe just write down a list of possibilities here. 6 could be 2 times 3, or it could be 1 times 6. And I'm going to kind of check out both of these numbers. What if my numbers were 2 and 3? 2 times 3 is 6, so that's good. 2 plus 3 is 5. That works out nicely. So my numbers are going to be 2 and 3. What if I had guessed 1 and 6 first? 1 plus 6 is 7, not 5. So this is not the combination of numbers that we want. It's not always going to work out this nicely, but the ones I'm going to give you today are going to work out pretty nicely, just while you get practiced up. So this expression then is x plus 2 times x plus 3. The two numbers here that I found that work nicely, they become these values inside of the binomial. And it's just because there's a pattern to it. That's all. Let's try a few more. Let's do x squared plus x minus 6. We've got another 6 going on here. This one, though, you can see there's a negative sign out here, and there's a positive sign here. So let's think about that. That means we want two values, b plus d when you add them together, you get the middle number, which is positive 1. Two numbers that add together to give you 1, and two numbers, those same numbers, multiply together to give you negative 6. Okay, well, let's look at our possibilities. Let's start again with this factor of with this product 6 here. I want two numbers that multiply together to give me negative 6. Well, once again, I've got 2 times 3, or I've got 1 times 6, and either one of those numbers could be negative. So I'm going to just put my negative sign out front here. I could have negative 2 times 3, or 2 times negative 3. Those will both give me negative 6. So, I've got some more decisions to make here. Well, I could have negative 1 and 6, or 1 and negative 6. So I kind of have 4 possibilities to check here. Well, let's check them all. Just really quickly here, I'm going to write them down the side. I've got negative 2 times 3, negative 3 times 2, negative 1 times 6, or negative 6 times 1. Now let me just add those things to see how they add together, to see if I can get that number 1 here. Well, I've got, let me start at the bottom here. Negative 6 plus 1 is going to be negative 5. Negative 1 plus 6 is positive 5. Negative 3 plus 2 is negative 1. And negative 2 plus 3 is positive 1. I'm not multiplying those, maybe that looks unclear. I'm just adding those together to see if they're going to give me the thing that I want. And I can see that this one right here, that's a positive 1. That's the thing that I want. So my numbers then are negative 2 and positive 3. So back up over to here. X, and what do I put in here? Negative 2 and positive 3. Let's just do a quick self-check to make sure that this is correct. To do the self-check, I'm going to do the opposite of factoring. I'm going to use the distributive property to multiply these binomials together. So x times x is x squared. I've got minus 2x plus 3x and minus 6. So just to again show you how I did that, x times x, well, actually in order here, I guess I did negative 2 times x, and then I did x times 3, and where's the last one? Negative 2 times 3. There we go. So that's how those things all multiplied out, and let's just see how we finished. X squared plus x, that's minus 2 plus 3, minus 6, which is what we started with, so that's nice. So this is the factored form of that expression. Okay. Let's take a look at, near the top of my page here, x squared plus x plus 1. So, okay, what I'm looking for now are two numbers that multiply together to give me 1 and add together to give me 1. So you might start thinking, well, this might have to be some kind of fraction-y thing or something like that. Well, you'll get some more practice with this too, but with some fancy math that we're going to learn in a little bit, you can actually find out that this is not factorable. You cannot factor this to find something that's going to work. You can't. There is no expression x plus something times x plus something else that's going to give you this expression when you simplify it. So you can fight with these for a little while, but some of them really just aren't factorable, and there's not a whole lot you can do about it. Okay, well, let's do one more that does work out. X squared minus 8x plus 15. Okay, so once again, I want two numbers that multiply to give me 15 and add to give me negative 8. So b plus d is negative 8, b times d is 15. Again, let's start with this number here, the 15, and think about its factors. 15 is 3 times 5. So I can write a big list of things if I want to, but I notice 3 and 5 right away, they combine to give me 8. The only trick now is making sure that I get the right signs. So I'm going to have an expression that looks like this, x here, plus or minus something, plus or minus something. Well, I've got two numbers that multiply to give me a positive number, So either both of these numbers, B and D, are both positive, or both negative, because I'm ending up with a positive value as a result of multiplying those two things together. It's positive 15. So they're both positive or they're both negative. And they add up to a negative number. So B and D add to a negative number. So if you get two positive things and add them together, you're going to get a positive number. So B and D, therefore, are both negative. So let's check it out then. If I have 3 and 5, if I have negative 3 rather, and negative 5, they will add together to give me negative 8. Let me just write that down here. So negative 3 plus negative 5 equals negative 8. That works out. And negative 3 times negative 5 is positive 15. That's what we're looking for. So those are our numbers, x minus 3 and x minus 5. Just to double check that again, x squared minus 3x minus 5x plus 15 is x squared minus 8x plus 15. And once again, just to remind you, this is the factored form that we were looking for. Okay. You know what? I've got enough time for just one more point before we finish this off, and that is that sometimes you have an expression that is a simple one if you can do a little bit of factoring first. So let's say something like this. Looks complex, but it has a common factor of 2 in every one of those. Those are all even numbers. So I could rewrite this as 2 times x squared plus 9x plus 14, which we actually did earlier, and this now is factorable to be 2 times x plus 2 and x plus 7. So look for that common factor first if you do have a trinomial that is not simple, and you'll be able to work it through possibly afterwards with the regular simple trinomial factoring. Okay, next time, complex trinomials. Thanks.